Hello guys, we are in. Today we revise chapter 5. Hope that you are not bored. and this time we want to prove strict 9. Okay, every time for this kind of question we read the fraction first, what we have and what we want to do. And what we have is already in the figure marked, and we want to prove this the strict 9, so we cannot use this one, adjacent angles on strict 9, because if you use this one, then if this already is strict 9, you no need to prove that. So this one cannot be used for this question, okay? You want to prove it is a strict 9, you cannot use the reason for it is already a strict 9, right? Okay, so, but this time it's easy, right? Because you can see, right, it is a strict 9, but we have to show the evidence. So we just calculate angle ABE plus angle EBD plus angle DBC, which is 60 degrees plus 30 degrees plus 90 degrees, and it is 180. So we can say ABC is a strict 9. Reason, they are all adjacent angles, right? And some number give you 180, so we say supplementary. Okay, adjacent angle supplementary. Question number 2, and yeah, again we check what we have in the question and whether they are already marked on the figures. Okay, and we have 48 degrees, 132 degrees, and the strict 9, which are CGD, and this one, and also this one. Okay, the blue one are all strict 9. So if they are strict 9, then we can use the reason adjacent angles on strict 9. Remember this way. In fact, you need to check whether all of them strict 9 before you use this reason adjacent angles on strict 9. And now, what we want to do, we want to prove EF parallel CD. Okay, we want to prove whether they are parallel. Oh, so what are the reasons that we can prove parallelize? And in fact, for any parallelize, we have all the corresponding angles and alternate angles equal and interior angles supplementary, right? So for us to prove the parallel nice, then in fact we can just do it in an reverse way, which that is corresponding angles equal, alternate angles equal, and interior angles supplementary. Okay, and this time, can you see which one we can use to prove these parallelize? I will find this one. Why? Because angle AHE plus 132 degrees 180 is an adjacent angles on strict 9. Remember, it is a strict 9, AHB, so we can say it this way. So angle AHE, which is 48 degrees. So if this one is 48, and in fact you can easily figure out this, then we can say this way. Exact shape, can you see? So we can use alternate angles equal, right? So we have to state this one, angle AHE is angle DGH 48 degrees. So we can say EF parallel CD alternate angles equal. Okay. Question number 3, and we have all the straight line given. And first of all, we find K, and of course we can mark it first. EB, EBF, straight line, G, straight line, ABCD, straight line, okay. And then we find K, that's easy, right? Because K paths for K must be 180 reason. EBF straight line, so adjacent angles on straight line. So left side we have altogether 5K, 180 degrees. So K is 26 degrees, right? So now for part B, we want to prove EF parallel GH. Remember, you can see EF originally is not given to parallel to GH. So it seems they are parallel, but you remember, always remember they may not be. Okay? So in fact, we can use mainly 3 reasons to prove parallel. And this time we try, maybe we try this one. This 4K, 136. Why? Because 4K include 4 times 36 degrees. Give you 144, right? 144 plus 36 is 180. So we can say this one, like this, just like a C shape, right? And they are interior angles. So we can say angle FBC is 4K, which is 4 times 36 degrees, 144. And angle BCH, 36 degrees. So we say FBC plus angle BCH is 144 plus 36 degrees, 180 degrees. So we say EF parallel GH interior angles, because they are interior angles. They're not equal, but together they are 180 degrees. Right. Question number 4. Again, we can specify all the straight line first. A, F, B, C, G, D, E, F, G, H. For X, okay, that's easy again, right? Okay. Okay. We want to find X. So because CGD is a straight line, so we can say 80 degrees minus X plus 6X is 180 degrees. Reason adjacent angles on straight line. And altogether we have 80 degrees plus 5x is 180 degrees. So 5x is 100 degrees, so x is 20 degrees. B, want to prove AB parallel CD. Okay, so in fact we can find these two angles to see whether they are equal, because these two angles are the corresponding angles of these lines, right? So we have angle AFG is 3 times 2x, 60 degrees, and angle CGH. And so they are the same. So we can say AB parallel CD. Reason, they are corresponding angles. There you go. Okay, remember, all the reason to prove parallel lines not include something parallel, AB parallel CD like this. No, we just have corresponding angles equal, alternate angles equal, or supplementary, interior angles supplementary. Okay. Well, question number 5, we have this 6, 9. 6, 9 here, and we just want to prove triangle ABC is an isosceles triangle. So ABC is an isosceles triangle, so it seems we just need to find this angle, right? If it is 75, then it's okay. Then of course it is. Why? Because this angle plus 15 degrees is 19 degrees, so this one must be 75. Okay, after you figure out the logic, then you can write angle CAD plus 50 degrees is 90 degrees. Reason, still remember? This one, this angle. The relationship between the blue angles, the exterior angle of triangle. Of course, if you don't want to use exterior angle, of course you can find this angle CAD by using angles of a triangle, but this one is plus half. Angle CAD, 90 minus 50, 75. So this you can have 75, and then you can say, so angle CAD is angle CBA ratio, or 75 degrees. So we have A, C is CB ratio. If it is a base angle, then if this is an isosceles triangle, the base angles are equal. And now we want to prove isosceles triangle, so we cannot use base angles isosceles triangle. We cannot use this way to prove isosceles triangle, because here we already have the isosceles triangle in the reason. So no, it's not what we want. We want to prove it is an isosceles triangle, so we just say this is CB size opposite equal angles, right? We have the equal angles, and the size of them must be equal. So we have AC is the CB. So we have triangle ABC is isosceles triangle. Okay. What's number 6? And also we can mark down all the strict signs first. 6, 9, 6, 9, 6, 9. Okay. And then we want to prove the parallel. Oh, sorry, it is a parallel line. Oh, so we can mark it. Remember, mark it. It's a parallel. And we want to prove equilateral triangle. Equilateral triangle, which means all the sides of the triangle are the same, and the interior angles also. So the interior angles of any equilateral triangle must be 60 degrees. So we want to calculate this one, this one. Okay, mark all those. Then after we understand this, then we can, what we can do. Can you see? Yeah. We can find this one first. This one is so obvious because it's strict line, so it must be 60 degrees. And then this one also 60 degrees because it's a parallel line, the corresponding angles will be the same. Then we can find this one. Angle sum of triangle, right? So after we figure out this, then we can write angle AED plus adjacent angles on straight line is already on a straight line. DEF is 9, so we have AD is 60 degrees. So we have 60 degrees here for horizontal angle ACB because corresponding angles this time is DF parallel BC. They are parallel because it's given in the question, so we can use corresponding angles DF parallel BC. It is not corresponding angles equal. Corresponding angles equals are proving the parallel lines, and now we are not. Okay, so we can have the reason that corresponding angles DF parallel BC. So after this, we can calculate angle ABC for 180 minus 60 minus 60. Angle sum of triangle. 60. So for all the angles of the triangle ABC are 60 degrees, so we can say from triangle ABC is an equilateral triangle. Okay. Now, oh, that's it. Okay, thank you.